Okay, guys, so tomorrow, we are going to be looking at our little book that has this first look at particle motion. So for those of you guys that took physics, this beginning part is going to be pretty easy for you. Those of you that didn't take physics, you might just need a little reminder. And then we also need to make sure that you know how to use your graphing calculator. Okay, so we're going to start off with, well, what did we learn back in Math 1, Math 2, Math 3 that can help us with this? Back in pre-calc. Okay, so we're gonna, we did this particular problem or formula was in our pre-calculus book, and we're just looking at if you threw something straight up in the air. So it goes straight up and it comes straight down. So this does not take into account anything that's thrown at an angle. Okay, if it's thrown at an angle, then we have to get some trigonometry in there. So we're talking straight up, straight down. Okay, now you want to be careful because this is not a graph of the object falling. This is the position of the object over time. So remember, straight up, straight down. Okay, so this was our initial velocity. So if we threw it up, it would be positive. If we threw it down, it would be negative. This is our initial height. Okay, so this was actually right out of the pre-calculus book. We have a ball. It's thrown straight up from a rooftop 96 feet high. Okay, so there's my initial velocity right there. Okay, so now again, I want you to think, so we're throwing it up and it's just going to go over far enough that it's going to come straight down and not land right back on the person that threw that. Okay, so basically in Math 1, what we would have done is we would have learned how to make this graph, and we would have made a T-chart to see where is the ball at all different times. Okay? All right, so now let's graduate to Math 2. Okay, and we learned how to find the coordinates of the vertex and the x-intercepts. So the main thing that I want you to see in this class is the notation. So notation, notation, notation. So notice, okay, here it's a height equation. In calculus, we like to call them position equations, and we use S instead of H. So you're going to notice that this is when we're using position. Okay, so position as a function of time. Okay, so what was the height of the ball after 4 seconds? So let's say that this was on a test and that you're just going to use your calculator. Even if you use your calculator, you have to justify this. Okay, so that right there is important, where it says S of 4. Okay, make sure that you're using that notation. And even if I'm using my calculator, I'm going to show where this answer came from. So I would use a table in my calculator, and we'll look at that in a second if you're not sure how to do that. And so I don't need to actually calculate each piece and show that. I just need to show where did it come from. Okay, the other thing, super important, your units. Okay, don't forget those. Okay, so this tells me after 4 seconds, the rock was 160 feet up in the air. Okay, how long did it take for it to reach its maximum height? So let's think of what we're talking about. How long did it take to get to its maximum height? Well, we want the x value of the vertex. So the x value of the vertex is negative b over 2a. Okay, so, and in this case, it's time. So I'm going to go negative b over 2a. I believe it's exact. It comes out to 2.5 seconds. So got this, and I would show that t equals. Okay, the maximum height of the ball, well, that is s evaluated at 2.5 seconds. Okay, so s of 2.5. And again, I'm going to use my calculator to find that, but I'm going to justify where it came from. And I will get that s of 2.5 is 196 feet. Okay, don't forget those. Okay, at what time will the ball pass the rooftop on the way down? Well, it goes up and it comes down, and the roof, we know, is 96 feet off the ground. So we want to know at what time is it 96 feet off the ground. Okay, well, I can see that it's 5, but again, I have to prove where did that come from. Okay, so I want to know when is S of t. Okay, so that's what I'm thinking about right there. Okay, so I'm going to go, so when does 16t squared plus 80t plus 96 equal 96? Well, if I subtract that, it's going to be 0. And I can factor out a negative 16t. So t equals 0 or 5. Now, this talked about on the way down. So this is saying at time 0, the rock was 96 feet up. Okay, so we're going to use 5. Okay, so we have our t equals, and we have this, and we've proven where that came from. Okay, so now notice what we have. Average speed. Okay, I want you to think average rate of change. That's all that this is. So average speed is just a change in position over a change in time. Okay, so average speed is going to be the slope of the secant line. Now, it's really important that you look at like how I'm going to make this notation, because that's going to make it easier when we're reading these things called velocity graphs. Okay, so the change in position, that's just the change in y value. That is s of 2 minus s of 0. And I want you to show this part right here, because that's just a really good habit to get into, because you'll see that things can get a little bit confusing when we start talking about velocity and acceleration, and if we should be using a velocity here or a position. Okay, so good habit to get into right there. Okay, that is just 192 minus 96. Okay, and then we want to make sure that we know our units. Position is in feet, time was in seconds. So 48 feet per second. And I could say something like, average speed right here. Okay. And when will the ball strike the ground? Well, it strikes the ground when the height is 0 or the position is 0. So when s of t is 0. So negative 16t squared plus 80t plus 96. I'm just going to factor out a negative 16. Okay, so I'm going to get t minus 6, t plus 1. And then this negative 16, I just divided both sides by negative 16, so that's why that's gone. Okay, so t is either 6 or t is negative 1. Okay, well that doesn't make sense. That's not in our domain. But if you're wondering where it came from, if this graph was extended and I went back here, it would be at negative 1. Okay, so S of t equals 0 at 6 seconds. Okay, so what I want to make sure that you can do is that you can use your calculator to find this. So I'm going to make another video on the calculator, just in case you don't remember or you didn't learn. That's it.